Let's talk about one more special feature, XY mode. Normally we display voltage vertically and time horizontally, and that makes sense because we want to know what's happening with our signal through time. But occasionally we want to compare two signals against each other, and that's what XY mode is. In XY mode, we show one signal as voltage vertically and one signal as voltage horizontally, and we do that with the display button. So we press the display button. Display gives us our display menu. It allows us to increase or decrease our contrast. It allows us to choose whether we show continuous lines or dots. And it allows us to choose either YT, that means Y is voltage and horizontal is time, or XY. So let's go back to our normal YT. The XY mode always shows us channel 1 and channel 2. So let's take a look at, in the time domain, what's on channel 1 and channel 2. And here you can see they look pretty much the same. I'm putting a 1 kilohertz signal into a 10 kilohertz filter. Let's go to XY mode. What we see is the input pretty much is the same as the output. How do I know that? Because when the input's at 1 volt, the output's at 1 volt. When the input's at 2 volts, the output's at 2 volts, etc. There's a little bit of difference between the input and output. That's because there's a little phase difference. Our filter does have some phase difference, even though it's 10 times below our F sub C. Let's go back to XY mode and look what happens when we increase our filter up to F sub C, which is about 10 kilohertz. Well, the first thing we notice is that our signal's down by 3 dB, as we'd expect at F sub C. We also see that our signal has been shifted slightly. There's a phase difference. Let's take a look at what that looks like in XY mode. So in XY mode, first of all, we no longer have a perfectly, our oval is not at 45 degrees. It's a little flatter because our output, which is on the vertical axis, is smaller than our input, which is on the y-axis. And we notice that there's a big hole in the center. That's our phase shift. As I go up in frequency, we expect two things to happen. I think I can probably go to a slightly larger display. As I go up in frequency, we'd expect our oval to flatten because our output's going to get smaller, even though the input's the same size. And we'd expect the whole thing to shift to the right because we're going to get more and more phase shift. So, and we see that. We see that as we go up, our output is getting smaller and smaller, and we've rotated to the right. We've got more and more phase shift. I'm going to go back down. That's 7. And as we get to lower and lower frequency, let's go below 1 kilohertz, what we'll see is the phase shift almost entirely disappears. That's 100 hertz, and there's almost no phase shift. And when there's no phase shift, the input equals the output, and that gets us a perfect 45 line because the input's 1 volt, the output's 1 volt. The input's half a volt, the output's half a volt. Always go back to YT mode, and we should see that the input and the output pretty much look like the same thing. So we don't use XY mode very often, but we will occasionally to see what the output of a circuit is with respect to the input of a circuit.